So I'm going to talk about this lab, which is Lab 0101. It is due this Sunday. Okay, now the first thing I want to point out, and I pointed this out yesterday to my in-class, my online students haven't seen this, is I'm changing the format this semester so that all of your coursework is submitted in this all coursework repository. If you already opened up this lab like maybe 2 days ago, it had you create your own repository and then share that repository with your instructor. And that's how that's the old way that I'm running this class. Now I'm just trying to have everyone submit all of their work in this all coursework repository. I believe you guys, I can tell who has accepted their repository. I can look at my classroom and here it is right here. And I can look at this assignment and I could see who has at least pushed. And so like I could see, like, that doesn't mean that Ben hasn't cloned his repository. That just means Ben hasn't necessarily pushed anything yet to me, right? So if you're looking at my screen share, Ben, I'm looking at your name here. It says not submitted. But nonetheless, these are my students, and I could see some students have pushed some things to me and some have not, and that's fine, right? Nothing is due yet, so there's no right or wrong here, okay? But if I back up, it does seem like, well, maybe a few people might have not cloned this. Anyways, if you're struggling setting up your all coursework repository, let me know. I'll help you get set up. In there, though, there's not a labs folder. Okay, so like if I just look at Ben's repository, like this is what I gave everybody, right? I gave everybody a final project folder and a hands-on test folder. And if I were Ben, I would probably, copy this URL, and then I have to clone this. Right, so I would have to clone this, I would say maybe on my desktop, and you guys are very familiar with GitHub desktop. Maybe you're familiar with TortoiseGit. I like TortoiseGit. I would clone with TortoiseGit. Okay, now this is my remote URL, and that's cool. I might even change on my desktop. I might even call this all coursework, and I would even put AWD like 1111. This is just the folder name on my local computer. Okay, so it doesn't have to be the same folder name on your local computer. And you do this cloning process, and there's not a lot there. And then here's my all coursework for Ben. Okay, now the first assignment on this lab, says, hey, go ahead and create a labs folder, and then create a lab 0101 subfolder. So if I'm Ben, again, I'm going to come into here. I'm going to create a new folder, and this will be labs, plural.
I thought I already did that.
No, you did, Ben, but if you did, you probably didn't push it. Does that make sense?
Yeah.
Okay, so because you didn't push it, that's why I don't see it.
Right.
Okay, so I'm not going to push this, so don't worry about it. I'm not going to screw with you here. Okay, so in this labs folder, I'm going to make another subfolder called lab 0101, something to that nature. And then this is going to be where you submit your source code. Okay, so I can open this with Visual Studio Code. I just right-click it, open with code. And this is going to be where Ben puts his source code for Lab 0101. Now, again, let's see. A Git repository was found in the parent folders. I'm going to say no. I'm not interested. I'll say never. I open the folder that I want to open, okay? Okay, so this is where this is going to be. Now, in the future, FYI, all of our labs are going to be kind of like building into a final project, right? So this is one of the couple labs that don't build into something else because we're just getting started with JavaScript. And if you kind of come into here, so we've done that, submit your source code in that lab folder. We're going to go ahead and scroll down. And it says create an index MJS. Now, first off, you might wonder, MJS, right? Remember the M stands for modular, module. This is the new file format since about 2015, ECMAScript 2015 or ES6. It's weird because it's ECMAScript 2015 or ES6. The years don't match the version number. nonetheless, this new file extension is not just JavaScript anymore, it's modular JavaScript, so it's using this new syntax. And so we're just doing hello world, and so this really isn't important, but I could just do index MJS and console log hello world. Okay, and I save that, and if I open up my terminal, okay, now remember we're using the node command. All right, now I haven't lectured on Node yet, okay, but Node, we have said that Node is a runtime environment where you can run JavaScript outside of a browser. Well, this terminal is not a browser, right? It's not Chrome, it's not Firefox, right? We're going to run JavaScript outside of a browser. We're going to run it right here in the terminal. So using Node, we can run JavaScript. And my favorite hotkey is as you start to type in a file name like index, literally if I could just type the letter I and hit tab, it's going to fill in the file name. Okay, if you had like an index 2 and you hit tab twice, it would go back between index and index 2. I could just keep hitting tab and it would kind of go back and forth. And there's our hello world using Node, which is a runtime environment to run JavaScript outside of a browser. Okay, so there's hello world, and that is essentially what we've shown here. Congratulations, you've written your first script using Node. Okay, now the rest of these labs are just writing JavaScript to solve problems and running the JavaScript files using Node in the terminal. Okay, again, this is just writing JavaScript. And some of these exercises are easier than others, and let's talk about it. You know, these best practices, please read these best practices. I've lectured on these best practices, you know, talking about arrow functions and the different ways to declare functions. And we're going to be using template strings all over the place. By the way, these template strings, that character right there is called a what? What is that character called? Backtick. Right? It looks like a single quote, so a lot of people get screwed up there and they put a single quote, but it's not a single quote. It is a backtick, which is the character above the tab key on your keyboard on the left-hand side, right? So if you see a backtick, that is different than a single quote. Okay, so these template strings are how you do concatenation, right? String concatenation with your variables in a very condensed syntax. So template strings are awesome, and they're condensed syntax, and I'll be using them all over the place. Blah, blah, blah. Pad start, you might end up using pad start in one of the labs, talking about pushing things onto an array, finding things in arrays. Okay, miles per gallon calculator. Now, to get started doing this one, notice this is mpg.mjs. So I'd come into here, new file, mpg.mjs. Okay, now accept user input using the readline module. So I'm going to click on this. It's going to open up a new tab. And this is how we are going to get user input in using our JavaScript. Okay, now you're going to notice there's a promise-based API, a callback API, and then there's async await. Notice the keyword await. So we are using not the promises-based API, but we're going to end up using the callback right here. Import star as readline. And so it boils down to, this is my example that I like using. And notice this little toggle here. Okay. CJS, common JavaScript, and ESM are ECMAScript modules. Okay, ESM, new syntax, CJS, old syntax. Okay, we're going to be using the new syntax, ESMs. Okay, so when you get to this page, make sure to toggle to the new syntax. Okay, and you're going to notice when this new syntax, we're doing imports instead of the require statements. When you see require statements, again, that's kind of the old syntax, whereas you're using imports and exports, That's the new syntax. So I'm going to use ESM. I'm going to copy this, go here, and this is my template. Okay, I'm going to save this, and I'm just going to run node, type in the letter M, hit tab, hit enter. As what do you think of node? It's cool. And then thank you for your feedback. It's cool. So all we're doing is we're asking the user, what do you think of node? Notice the keyword await. You have to have that here. I've never tried it without it, but I'm sure I have by mistake, and I'm pretty sure if you do this, I'm guessing it's going to break. Yeah, there you go. It doesn't work, right? Because this question returns a promise, and we have to await that promise. Okay, we're going to talk about promises and callbacks and async await. But for right now, the rule that you got to be familiar with is anytime you ask a question to the user, you have to await the response and store that in a variable. And then here we're using backticks to just spit that answer back out to the user. So get some input from the user, spit it back out. Yes, sir. Yeah, console log is your console write line. That's right. And so this is our template. And so we can do, I would probably comment that out and just comment that out and have that there for reference on how to get input from the user. By the way, the biggest mistake I see when students are new to this is they think that's an R1, but it's an RL. RL representing a read line. Yeah, it's a read line. So you might, get like MPG equals and await RL dot question. Enter the miles driven. So therefore MPG, you would say miles driven. Okay. So enter the miles driven. Okay, now we might say why we can say, hey, do this code while not miles driven. And so let's go ahead and, by the way, let's go ahead and talk about this for just a second. What data type do you think miles driven will be? Remember, JavaScript is a loosely typed language, so it's basically going to pick the type. Remember the numbers, the bools. What data type do you think the runtime engine is going to assign here?
Number.
Good assumption, because we are asking for a number. Okay? Why might it not be a number, though?
Wouldn't it be a string?
Why would it be a string?
Because we're not converting it to a number.
Right. When you're right. So it is a string. A number is a good guess because we're asking for a number, and that's a safe assumption. But it actually we're just asking the user for an input, and they could type whatever they want. Mm-hmm. Therefore, question. If you were to look at how this method, what it returns. You see right there, it returns a promise of a string. Do you see that? So it's actually going to return a string. All right. So what I want to do is I want to parse that string into a number, so I can check it to see if it's in fact a number. So I'm going to say miles driven equals parse float miles driven. Okay. I'm going to update, and by the way, that's no longer a const. That's now a let, because we are reassigning it. Okay, so I'm going to go ahead and take miles driven and parse it to a number, data type, and we're telling it to be a float, meaning it take, and it says while not miles driven. Okay, so we've effectively created a loop that says as long as this is falsy, continue to ask the user for an input. So now if I run my program and I say 10, why is that not working? Scoping issue. Notice I declared this miles driven inside of my do.
So I'm working the while.
So the while, it's actually out of scope. It is the block scope of that variable is right there in the highlighted code. That is considered out of scope. So we actually need to declare it, let miles driven here, and then we can just assign it in our do while. Okay, so let's declare it here, and in fact, you might even, set it to like a null value or something here. I don't think that makes a big difference. Now let's run the program, and if I say 10, okay, well, any word is in a loop. Okay, and we're using that truthy falsy thing to say while not miles driven. But if I say -1, -1 works. Why? Because -1 is truthy. Right? So I also might consider adding an or miles driven is less than 0. Now that loop's going to loop. If I say 10 t exclamation point, if I say -1, okay, now if I put in 20 miles driven, the input is accepted. Okay, so this is a pretty simple do while loop that is doing data validation, right? You're doing a little bit of data validation. I think it asks you display an error message if either is not a number or less than 0. So that loop handles those conditions. And the error message doesn't have to, be a big error message, but it shouldn't accept it. You could be more explicit here and say, please enter the miles driven, and you could say something like number greater than 0. You could ask the user for a number greater than 0. And please enter the miles driven number greater than 0. And now it's a little bit more user-friendly. They know what they're accepting, and if they type in anything else, I would accept that as an error message if you continually prompt the user and with the same input. Okay?
Wouldn't we use less than or equal to them in our comparison statement?
Yeah, you could if you want to accept 0.
Right.
Yeah. So the question that's a valid question. So if I say 0, we're getting it to loop, which is I would not want to say 0 miles driven. I would at least assume greater than 0. Yeah. So 0 is not being accepted, which is what I would prefer.
Okay.
Yeah. But if I say 1, that's accepted. So okay. So that's a little bit of a JavaScript to do that part. And really, that should get you pretty well through this first one. Because then what do you do next? You have to say gallons used, and then you can do the math, and then you output the math, right? So at some point, let MPG equals miles driven divided by 20, whatever. This would be gallons used. You get what I'm pointing. So first part, generally speaking, input, get the input. At some point you're going to do some math, and then you're going to do some output, right? Very simple 3-part process. Get the user's input, do some math based on that input, and then give the user some output is the general workflow of all of these programs. Okay, and it says, hey, round to 2 decimal places using 2 fixed. Okay, temperature converter, very similar process to miles per gallon. These next 2 exercises, by the way, let's do taxable income for 2023. That's the last taxable year. So we're going to update this. Singled or married. By the way, you can be married filing separate. This will be single filing, 2 L's, jointly. Okay, So let's talk about this problem. Income tax. How many people have worked? Raise your hand if you've worked a job ever in your life. And therefore you've paid taxes. And do you understand how taxes are calculated? Probably most people don't. Most people do not understand taxes and how they're calculated. So you have, in order to solve a problem with JavaScript, you have to understand the problem. You have to understand how to solve the problem in the real world before you can start to solve it with a computer. Okay, so taxes are not flat taxes. Okay, so you've heard of your tax bracket, right?
Yep.
Okay, so most people think that they just fall into a category, like a percentage, like, oh, my taxes are 25%, and I earn $40,000, therefore my taxes are $40,000 times 25%, and I owe $10,000 of tax. Okay, in that example, that's what's called a flat tax. Okay, a lot of economists would argue the benefits of flat taxes, but that's not how we are taxed in the national, because you pay national taxes you pay to the United States federal. Thank you, federal taxes. That's the word I was looking for, and then you pay state taxes. So our federal taxes are not flat taxes. The actual word is escaping me. I think it's what do you call it? It is called graduated, or there's levels. What do you call it? ChatGPT is going to help me out here. ChatGPT. What is the opposite of a flat tax? A progressive tax. Thank you, ChatGPT. This is called a progressive tax system. Couldn't even think of the name. I know how the math is done, but I couldn't think of the name. Progressive taxes, you have to understand how to calculate these if you're going to solve this problem. Okay, so I'm going to walk through the math with you so that you can solve this problem in code. And so we have to pick a scenario. Again, you're either single or married filing jointly. This problem asks the user for either single or married filing jointly. The math is the same for either category, but the brackets are different. Okay? So there's a big if-else. If you're single, else you're married filing jointly. Like that's the first input that you got to get for the user. It's a big if-else. Okay? And let's just say that they're single. Okay? Let's just say, for the sake of this example, we're single, and you worked, and how much money did we earn? Someone give me a number. $50,000. Okay. So we would agree that $50,000 gets us up to the tax rate of 22%. Everyone with me here? Okay. Now this is a progressive tax system, meaning the more money you earn, you pay higher taxes on the higher dollars. The lower dollars that you earned, you pay lower taxes. So from your $0, the first $11,600, you pay 10% on. Did you know that? Your lower earned dollars, you pay a lower tax rate. That's why taxes are so hard. Then from $11,601 to $47,000, you pay 12%. And then from $47,151 to your $50,000, which is all the money you made, for those last, what is that, $2,000, $3,000? On those $3,000, you pay 22%. Okay, so let's get out a notepad and let's figure out how much money we owe. If we earned $50,000. Okay, so we're gonna calculate taxes on 50 using some napkin math, right? Some back of the napkin math. Okay, so we said 10% for 11,600. So the first $11,600 we paid 10%. So let's bust out the calculator. The first $11,600 we pay 10%. So we multiply 11.6 by 10%, and we owe $1,160 of tax for your first chunk of change. So again, the math here is 11,600 times 10% is what you owe in tax, 0.1, equals $1,160. $1,160. Right? This is for your first tax bracket. For your 10% tax bracket. Now, for this range of money, from 11,601 to 47,150, we owe 12%. So what do? Is we take 47,150, which is the upper end of that, and we subtract off the 11,600, because that's, what is that, $36,000? You see that $36,000 is basically that entire bracket. So we have to figure, the next math is we got to figure out how much we're paying at 12%. So 47,150 minus the 11,600, and I'm gonna add this as a step. 47,150 minus 11,600 equals 35,550. 35,550. Okay. So this 35,550, yes. Why wouldn't we? Because you pay it kind of, when you're progressing, you progress from the bottom. You progress from the bottom. So the first $11,600, you pay 10%, and then the next $35,000, you pay 12%. Like this right here, the next 35K, you pay that 35K at 12%. And I guess the way to answer that question is you just got to start from the bottom up, because what you asked is 50 minus the 47. It's kind of top down. One more time, what is it?
Like, I thought it was going to be the 50 minus the 11.6, and then what we had from, we multiply that, get our answer, but then what we had left from that 50,
Yeah.
then that would be what we would be getting at 12%.
And maybe we're coming to the same conclusion, just differently. I'm not sure, but I would tell you that, maybe is my answer to your question. I have to sit down with you and kind of see how you're stepping through. But I guess the point is, my math is now this 35,550. We owe 12%. And so let's do that math. 35,550 times 0.12 is $4,266. $4,266. So far through the first two tax brackets, I owe $1,160, and in the second bracket, I owe $4,266. We got one bracket left to go, but all we earned was $50K. We didn't earn anything more than $50K. So we got to take $50K minus $47,151 to figure out that there's $2,000 whatever dollars left of tax to pay, that we owe taxes on, I should say. So 50,000 minus 47,151. This is how much we owe left on taxes. We owe a little bit more at that 22%. So I'm going to tab this over to say 50 minus 47,151 equals 2849. So we're going to take 28,249 times 0.22 is that last tax bracket rate equals 2849 times 22%. $626.78. 626.78. Okay, so we add these numbers together. Basically, we add this plus this plus this. Those three numbers we add together, and that's how much tax we owe. The 626 plus the 4266 plus 1160. Our total that we owe in taxes for the year on $50K in the 2024 tax bracket, which is due April 2025. I guess I'll put the 2024 here because that's what the link gives you. The total that we owe is $6,052.78. Why are we doing this? Because sometimes to solve real world problems, you got to understand the scenario. Sometimes the scenarios are complex. Taxes are a complex problem to solve. Okay? If I lost you on my tax example, and I understand why I would, right? If I lost you on my tax examples, let me zone you back in here for just 1 second. Developers often, when they're going onto a job, coding is not necessarily the hardest thing they have to learn. The hardest thing oftentimes that they have to learn is the real world problem. I had a graduate one time go to work for Anheuser-Busch brewing beer, and he goes, it blew my mind how complex Anheuser-Busch brewing beer process was. I mean, the systems that they have in place, the temperatures, the controls, it blew my mind. It was so hard to understand the system that I had to write code for, because if you can't understand the real world problem, you can't write code for it. Okay? Taxes are a fairly complex real world problem. So yeah, we're going to give you some challenging real world problems that, again, it's a real world problem.
If you work in the financial sector.
If you work in the financial sector, you got to be able to figure out how to calculate taxes. I guarantee someone at TurboTax knows this stuff pretty well. Someone wrote TurboTax, you know? So in our example, you know, I would even put, for example, $50,000 as a single taxpayer would owe $6,052.78 of taxes. Okay? And again, the main point is I wanted to step through this is it's a progressive tax that we owe at the federal level, and that's the problem that we're solving here. I think you'll find once you get into it, you kind of, your code will develop some repetitiveness to it. Once you kind of figure out the flow and the math, there's a little bit of a repetitiveness to it, and it's not as hard because of that repetitiveness. Okay, so the third problem this week is a challenging problem. Okay, so these first two are not as challenging. The next two are the challenging problems. Okay, the third problem is challenging, and the fourth problem is challenging. This fourth problem might not look like a whole lot. You did this. You did this. Do you not have your code solution from last semester? Maybe.
Extra credit.
Made it extra credit?
Yeah, so like number one did it.
Oh, okay. Okay. Well, that was first year. You were beginners. You're not beginners anymore. Time to step up to the plate and hit the ball. Okay. Why is this a challenge? Because there's many loops here. There's like 2 or 3 or 4 for loops. There's if statements. There's some critical thinking that goes into solving this. There's nested for loops where you're doing, the inner loop and the outer loop and one times the other. Yes, sir.
One question I do have is the formatting, like the spacing, because obviously like you have 2 characters, you have
I'm not going to be brutal on the formatting. Okay. If you can give me a table and the spacing's off a little bit, I'm not going to deduct points. Okay. I would encourage you to go back to your solution last semester if you did solve it last semester. But this is one that, yeah, you guys remember, and it's challenging because it is a harder problem to solve because there's many loops, there's if statements, there's things of that nature, and it just requires a little bit of critical thinking. And so all that just to say, we've got 2 more days in class to continue to work through labs. I'm hoping that you're winding up with the free code camp at this point, and that you're moving forward into these labs so you can spend the next 2 days on these labs. And I think the people that have spent 8 hours on free code camp have told me, yeah, they're either getting close to done. My understanding is taking 8-ish hours to get done with that free code camp on average. So nonetheless, I will let you guys get to work. Ask questions when you got them.